Let's take a look at the f of x function written here. If we use the rational root theorem, we find that it has a whole lot of possible roots, 18 to be exact. Fortunately for us, we can narrow down this list of numbers using what's called the upper and lower bound theorems. How this theorem works is that we can choose any number here. So let's just choose 6. And we can use synthetic division and analyze the result. So if we use synthetic division, remember we put the coefficients in for each term in our polynomial function. And then we can use some simple multiplication and addition to get a result. So if we divide our root of 6 in, we're going to get 1. 6 times 1 will be 6. If we add up -6 or -4 and 6, we get 2. Multiply 6 and 2, 12. If we add here, we're going to get 21. If we multiply by 6 here, we should get 126. And when we add up -36 and 126, we get 90. And so this result probably doesn't tell us as much if we only knew what we did in section 3.2, right? 90 is our remainder, and we could make a polynomial expression with the leftovers here. And so, of course, if we have a remainder of 90, 6 would not be a rational root. But the upper and lower bound theorems says that if we look at the sign changes of our remainder, or of our polynomial here, so we have a positive, 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 and positive, which represents 0 sign changes, that tells us that 6 is what we call the upper bound of our roots. That means that there cannot be any root that is bigger than 6 in our polynomial equation. And that's great, because that means that our roots cannot be 9, 12, 18, or 36. We don't even have to test them. We can do the same thing with a smaller number. Let's go ahead and test 1. So if we use synthetic division, testing 1, so I'm going to get 1, then -3, -3, +6, +6, -30. We see from our result here that first, okay, our remainder is -30. That means 1 is not a root. But we go from positive to negative to positive to negative. We see here that we are alternating signs. When we see alternating signs, this means that we have found what's called our lower bound. That's great as well. That means that no number less than 1 could be one of our real roots. And so we don't need to test our roots of, well, anything that's negative, right? So we've already tested 1, so we wouldn't have to test -1, -2, -3, -4, -6, -9, -12, -18, -36. We don't have to test them. And that's really great, because of our 18 possible roots, we have now narrowed our search. Only roots between 1 and 6 can be our answer. And if we take a look at our list, those possible roots are only 2, 3, and 4. Remember that 1 and 6, because we found the remainders, also could not be our roots. And so when we're solving this polynomial equation, when we do synthetic division, we're going to be smart and only test one of these 3 numbers.